Okay, good morning to everybody. Praise be the Lord, now and forever. And we're going to continue with this topic of the non-right triangle, the trigonometry that works in non-right triangle. Do you remember we were solving many exercises related with the cases of for the law of sine, for the law of cosine. But here's one interesting exercise. It's a historic problem. Okay, here it is. It's related with that Tower of Pisa. You can look in Italy, I think. And the problem is interesting because it's related with something real. So the famous Leaning Tower of Pisa was originally 184.5 feet high. At a distance of 123 feet from the base of the tower, the angle of elevation to the top of the tower is found to be 60 degrees. Find the angle RPQ indicated in the figure. I'm gonna show you the figure, and also find the distance from R to PQ. Here are probably two ideas that you're not clear at all. Here is the figure, and I want to explain you, for example, what means angle of elevation. What means angle of elevation? So, for example, this is related with how we look at things. Normally, our eyes looks horizontally, and they create like a type of horizontal line. Okay, normally our eyes looks like this, horizontally. So when you move your eyes looking upward, you change that line and you move it a little bit like this. Okay, to look something that is like in front of you, but it's like higher. Sometimes you move your head too, and it counts. It counts to make this angle, because normally we look like this, making that straight line. And if you look upward, you create an angle, and that angle is called elevation, angle of elevation. Okay, and that's the situation that's happened here. Someone was here, and then the angle of elevation made it is like that. So that angle goes like this, Okay. So what happened if instead of look upward, you look downward, and you change your view and you're looking like this, okay? Looking downward. So that angle you create is called angle of depression. This is more useful in physics, but to have clear what does it means in the context of this exercise, I want you to be sure about how this works. Okay. Is it clear? Do you have any question about elevation or depression? Elevation, looking up, depression, looking down. Okay. So we're gonna concentrate in this exercise, and look, the problem is asking us, is giving us the information here in the picture. Of course, you can look that better. You have the triangle, as you can see here. The triangle works with other letter. We have been working, if you remember, we work with ABC. Here works with PQR. No matter is the same. What matter is that you identify and fit the information problems gives you, and fit to the problem question. For example, it is asking you to find the angle RPQ. Who can tell me what's the angle RPQ? Not the three angles, okay? Not the three angles. Do not get confused with that. RPQ is a way to name an angle. Which of these three angles is RPQ? You can use your drawings and you can show me what is this one. Circle it. Is it like this? Is it this? Is that the angle RPQ? What do you think? Circle the one you think is the angle RPQ. Because that's related with something you study. I think you studied that in fourth or fifth grade. Probably not remember as well, but probably someone remember it. It's related with the geometry. So nobody has an idea about what's RPQ? Okay, nice. Someone is showing us something in blue here. Totally agree. That angle is RPQ. That angle in here. Why is that angle? Okay, first, the P is in the middle, and then the other information, which is R, and then here Q. makes the opening or show us the opening of that angle. So always when you have expressions like this one, consider the expression that is like or the letter that is between, okay? The letter that is between is telling you practically what is the angle. We can call that one like angle P, of course, easier. Or we can call it like angle QPR, two ways or three ways to name it. But of course, this is the unknown we want to know. This is the unknown information we want to know, expecting to know. And in order to conclude that, we need to conclude then uh, what law will work, the case that this triangle is. And of course, one more information. It says, also find the perpendicular distance from R to PQ. The perpendicular distance from a point to a line, it's the perpendicular segment you can make in that triangle, okay? From that point to that segment, it's a perpendicular distance that you have to consider in order to do the exercise as well. So here is like the main idea. I already did this with other of your classmates, other of the seniors of this year, but I want to start the exercise with you. So that's why we're gonna move this to our whiteboard. Here we go. Here's the information, as you can see. Something that I'm gonna do is like recreate this exercise in just a triangle. Okay, that's why I'm gonna work with this information we have. So we're gonna join the points P and Q, then the point Q and R, then the point P and R, and if you see, that's the triangle we have. Of course, we're gonna fit the information to, in this case, we have that this angle is 60 degrees. This angle is 123 feet. This side, sorry, and this other side is 184.5 feet. Okay, once we have this clear, now we can move our image and just work with the triangle we have. Okay, the triangle we want to solve. I'm doing this because I wanted that we work with the expressions we have been working. I mean, decide what's A, what's B, like we have been doing it just to show you that's practically the same, just that require we solve on your thinking here. So decide, we can decide what's A, what's B, what's C. What's A, what's B, what's C? You can decide it. Okay, I'm gonna decide that one like A, that one like B, that one like C. It means that I know the side A, I know the side C, but I don't know the side B. It means too that I know the angle, I don't know the angle A, I know the angle C, and I don't know the angle B, but the angle B is something that we want to know. Okay, this is essentially what I'm doing is translating the exercise we start, this one, into the type of exercises we have been solving. Okay, so you decide if you want to do it like that or if you want to work with PQR, it doesn't matter. Just to show you how the formulas fit in here. So what we should do, what we have been doing always with this type of exercise. What's the first thing we should do? Nobody?
Identify the case.
Okay, identify the case. What case is this one?
Side angle.
Side angle. Because you know, this side, this other side, and this angle. Of course, the angle is not between, that's why it's not side angle side. What law works with this one? I think you're clear that the law working here is law of sine. Okay, so how or what's the information we can conclude right now? Remember, our objective is first find the angle B. Then we're gonna have other need or other thing to do, which is related with a perpendicular segment. But right now we have to concentrate on it. So what we should do? Can we get the angle B like in one step or not? What can we get right now? That's my question. Angle B or side B or angle A, because the other information, we already know it. I mean, we know the side C, we know the angle C. Essentially, this is what we're going to use to conclude the other missing information. What's the missing information again? The angle A, the angle B, that's the one we need, and it's missing the side B too. So what we should do in order to conclude that? Or my question again, what's the only thing? I'm gonna make the question better. What's the only thing we can get right now?
I think that angle A.
It's just angle A. You're right. The only thing we can get right now is angle A. So you're sure, you're totally right with how this, I mean, you're totally clear with how this law of sine works, because we know the corresponding side A and there is the unknown angle A. Of course, know the angle A, then will help you with the angle of 60 degrees, the angle C, to conclude the measurement of the angle B. How? Okay, then I'm gonna ask you. But I'm agree with this analysis, and this is what I want, okay, when you conclude this type of exercise. So let's apply the property working with C over sine of C equals to A over sine of A. Of course, the unknown we're gonna get is A, because we already know that C is 184.5 divided by sine of 60 degrees. That's gonna be equal to A, which is 123 fifths. I'm gonna write 123. Over sine of A, which is the unknown. Okay, so here we have the exercise. We're gonna concentrate on it and we're gonna solve it. You can apply the zero product, the cross product property, the cross product property in order to solve that quickly, or translate to the other side, applying the skills you already win through all those years of algebra. So here we're gonna have 184.5 times sine of A, and that's gonna be equals to 123 times sine of 60. So everybody with your calculator, remember that we want to leave sine of A alone. So sine of A, it's equals to 123 times sine of 60. All that divided by 184.5. So we have to multiply this and get the result. Remember, we are going to have an answer, and this answer is always 0 point something. Why? Because here you're going to apply the trick of ants, and because you're going to work with sine inverse. Sine inverse just work with 0 point something expressions, okay? Or 1 or -1. But greater than 1 or less than -1, it will not work. You can try it your own. So here I'm going to give you an answer. What answer gives you? Nobody try it?
0.57.
And many more decimals, right?
Yes.
That's why we're gonna use the answer tree, okay? Not just gonna serve the answer like that. So let's get that 0.57 many more decimals. The guy who speak was saying, so it's gonna be sine of 60 divided by 184.5. That's gonna be 0.5773. Okay, many more decimals, and of course there are some more. The calculators cannot show us the other ones. I'm gonna save this in answer button. As you can see, there he is. And with that information I have, now I have to get the sine inverse of this, which is, it gives you
35.26.
95 or 35?
35.
35.26, like this, right? So you're right, that's the answer. I mean, 26.43, best rounding is just 26. So angle A is 35.26 degrees. So we already know the angle A, which is 35.26. I'm gonna feed the information in here. I'm gonna zoom it to feed the information better. 35.26, like you said. So this is the information we have. With this information, now we should conclude the missing information, which is the angle we have to get. In this case, it's angle B, but in the exercise, is angle RPQ. I don't remember what was it. Just to show you here again, it was, yes, the angle was RPQ, but we can conclude it right now in order to answer like the first question of this exercise using the 180 degree streak. So the measurement of the angle B, which is what we want, it's going to be equal to 180 degrees minus 60 degrees minus 35.26, which give us someone, nobody try, 180.
84.74.
84.34, okay, minus 35.26, it's 84 point, like you said, 84.74, okay? It has sense because normally the structures, the buildings, when they don't have inclination, they make some 90 degrees angle, okay? But that one that has a little bit of inclination, it's a little bit far away. It's a little far away to the 90 degrees, like 6 or 5 degrees less than that. That's why it has that inclination, okay? So it's missing one more thing. This one more thing is gonna be your hands, okay? Saying this because it's almost the time and I want that you solve it your own, of course. The problem is asking to us for one more thing. It is asking us for the perpendicular segment that starts in this point and it's perpendicular to the base we have in here. So it starts in this point and it's perpendicular to the base. What does it mean? It means that we want to find, we're going to have another exercise in here. Inside of this exercise is another exercise because there you have another triangle. I'm going to show you how this triangle is. Practically is this, the perpendicular segment that you have is that one. And the other line that the problems give you is this one. What do we know about this triangle? We know some information. For example, we know the measurement of that angle. We concluded right now. It is 84.74. 84.74. What else do we know? We know this is a right triangle because that's a right angle. Why? Because this segment is perpendicular and we want to know how tall is this. What else do we know? If you pay attention on details, we know the measurement of that side. What is the measurement of that side? You can tell me, what is it? Nobody?
84.5.
Excellent. It's 184.5. So look, what you have in here, it's a SOHCAHTOA exercise. So you should look for it, review it, and conclude what's the answer in here. You have the angle of reference, 84.74. You have one side, which is 184.5, and you want to conclude this one, the missing one. Probably someone will think that if it's possible to inclusively use the law of sine in here, it's possible. because you know the angle of the right angle is 90 degrees. So then you have again this case. Another case, I mean. In this case, we work side angle and side angle. In this case, you're gonna work side angle angle. Okay, this becomes to be the case side angle angle. You can use a lot of signs together, or better if you use that trigonometry in right triangles, because at the end, this problem is asking us for this. So screenshot that, it's almost time, and try to solve that exercise. I'm gonna zoom it, and that way you're gonna see it better. So there is the exercise that you have to try using SOHCAHTOA if you want, or it's like again the law of sine, in order to conclude that side, that perpendicular side. Okay, try your own, and next class, I'm gonna ask you for the final answers. Okay, if there's no any question or observation, it is time. I think we have to go to another class. So bye-bye, guys. Any question, any observation? No? So let's go to our next class. Bye-bye, guys. Have a nice day. And do the quiz.